Okay, today we're looking at the surface area of pyramids and cones, and we're also going to look at the volume of pyramids and cones. First of all, some terms we need to make sure we're aware of. What a regular pyramid is. Of course, we know what a pyramid is. It's got a base, one base, and it's got all the faces of a pyramid are triangles. But a regular pyramid is a little different because it is a pyramid with a regular polygon as its base. And you'll remember that a regular polygon is polygon with all sides are congruent and interior angles are congruent. Now the slant height is formed by that little cursive L, or another symbol for it is the cursive L. It is an altitude, which means it comes from the vertex to a side and is perpendicular. Altitude of a lateral face, basically one of the triangles. Sorry, my writing seems to be, I'm off today. Okay, so looking at this, you can see in this drawing right here, the slant height is perpendicular to one of the sides of the base. There it is right there, perpendicular. So let's look at an example here. I know we don't have any numbers on this first one, but let's go ahead and make some and see if we can solve this. Let's suppose that we have a slant height of 6 meters, and this is 5 meters. Well, the perimeter of my base is going, remember, it's regular. That means all the sides of the base are congruent. So that'd be 5, 5, 5, 5. 5 times 4 is 20 meters. Now we already said that the slant height was 6 meters. And the base, the area of the base is, well, how would we find the area of that square with 5 by 5? Well, 5 times 5 would be 25 meters squared. So that's how we have that information. If we have that information, now we use the formula to plug it in. We'll say that the lateral area is equal to 1/2 times the perimeter, which we said was 20, times the slant height, which was 6. Plug that in our calculator, and we get a lateral area of 60 square meters. Now, we're going to find surface area. Surface area, if you look at the formula, and the difference between what lateral area and surface area is, lateral area is the area of the faces, only the faces, not the base, just the faces, all the triangles. The surface area, on the other hand, is the area of all the faces as well as the base. So what we do, if you see the formula, that is my lateral area formula. So what's the lateral area? What is 1/2 times perimeter times length? We already figured it out up here. That's 60. And we're going to add that to the area of the base. Well, we found the area of the base to be 25. So what's the area of this pyramid? The surface area is 85 square meters. See that? All we did is we added the area of the base to the lateral area. Alright, let's look at the next one. Look at this picture. This one's a little tougher because, well, first of all, we can find the perimeter. The perimeter is going to be all the sides are congruent, so they're all 8. 8 times 4 is going to be 32 centimeters. Now be careful, because what we have here is not the slant height. This is the height of the pyramid, but it's not the slant height. The slant height would be, again, perpendicular to one of the sides of the base. Now what we do end up with is a triangle, which if the height is coming from the center here, if the whole thing is 8, all the way across would be 8. Half of that would be 4. So what we end up forming is a triangle with a height of 9. It has a length here of 4, and then this is the slant height that we are trying to figure out. Notice that's a right triangle. We can use the Pythagorean theorem to solve for that. And when you do that, put the Pythagorean theorem in there, you end up with radical 97 equals L squared, slant height squared. Well, if we figure out what that is to the nearest tenth, we get that x, or let's call that L, equals 9.8 centimeters. So that's how you find it. If you don't have it, you're probably going to use Pythagorean theorem to figure out, because we're going to use that right triangle that's formed with what we know. So now we're going to plug it into the formula. The formula is 1/2 times the perimeter times the slant height. Work that out, calculate that, and you find that your lateral area is 156.8 centimeters square. Now again, that's lateral area, so that's just the faces, the triangle faces. If we're looking for the surface area, we're going to take the lateral area, 156.8, and add the area of the base. Remember, it's a square, that's 8 by 8. 8 times 8 is 64. When you add 64 to 156, you end up with a surface area of 220.8 centimeters square. All right, now how does that relate to a cone? Well, here's the formula for a cone. Again, the lateral area is not the area of the circle, it's just the surface of the cone, not the circle. When we find surface area, we include the circle. So, a little different here. We have the radius is 6. They don't give us the slant height. Do you notice that? Well, and actually, I think that the 7 is the slant height here. So we'll go ahead and say that 7 is the slant height. If it's not, that's okay. For the sake of this problem, we'll do that because it is kind of confusing. But lateral area is equal to pi times the radius, which is 6, times the slant height, which we're saying is 7. Calculate that, you end up with 42 pi. We'll leave it in terms of pi for now. We're talking inches. Sorry, that would be lateral area. Now, it asks for the surface area, so the surface area is my lateral area, 42 pi, plus the area of that circle, which is pi r squared. Well, that's going to be pi times your radius, which is 6 squared, or basically 32 pi, which when we add that up, we end up with 74 pi. And if we need our answer to the nearest tenths place, we would get that also. So that's in terms of pi, and this is rounded 245 square inches. And again, that's surface area. So we just find these, we find the radius, we find the slant height, plug it into our formulas, and we find our answer. All right, let's look at the volume. Okay, the volume formulas are there. Now, the volumes are different because we don't use slant height for either volume. We use height. Height, again, is coming from the center perpendicular up. How tall is this pyramid? We're going to say that we've got sides of lengths of 5, so the area of my base would be 5 times 5, which is 25. We'll say that that is meters. So that's 25 meters square. Now, how tall is this? Well, let's go ahead and say that it is, we don't have a height for that. We'll say it's let's say it's 5.5 just for fun. We'll just pick that number out. 5.5 meters square. So we have to plug that into our volume formula, which is 1/3 times the area of the base, which we said it was 25. 5 times 5 is 25. Times the height, which we went with 5.5. Again, I just got that 5.5. I made that up. I just added there. There's no calculation to figure that out. When we multiply that, we end up with a volume of 45 8/10 cubic meters. Cubic because we're talking volume. Okay, so what you need to find is you need to find the height and you need to find the area of the base. Now if we've got a cone, we need to know, let's zoom in a little bit, the radius, because there is our formula for the volume of a cone. So the radius in this case, we will call it 6. So our radius is 6. And we'll say in this case, well, suppose we don't know the radius. Suppose we know that the slant height is 7. How are we going to find the height if the slant height is 7? Okay, and if the slant height is 7, then we can still find the height of the cone because we have a right triangle with these sides. And of course we'll use the Pythagorean theorem. 36 plus h squared equals 49. We end up with h squared equals 13. Square root of both sides. And h equals, rounded to the tens place, 3.6. Then we just plug it into our formula. And actually I wrote that incorrectly here, didn't I? That should have been 1/3 on that first one. So this one would be, the volume is 1/3 times pi times the radius, which is 6 squared, times the height, which we calculated to be 3.6. When you calculate that, you should end up with a volume of 135.7 cubic meters. Okay, homework assignment, look at these, numbers 1 through 6. You'll see that you don't have the slant height because you're finding lateral area. You need to find the slant height of each, or the surface area. So you're going to use the Pythagorean theorem with those right triangles that are formed. Same thing for 7 through 12. These questions here. Volume questions. The volume questions here, you will be using that volume formula from the notes. You have the height on these, and you can figure the radius if you're given the diameter, so you should be fine on those problems.